Yesterday in class, we wrote conclusions about what cools faster, soil or water, and what heats faster, soil or water. And we discovered the reasons why soil cools faster and water cools slower, as well as why soil heats faster and why water heats slower. So this is what we've been working on the last few days. And if you remember, we drew a picture like this yesterday in class to kind of explain why that happens. So today I'm not going to get into exactly why it happens because we've already done that. We're going to talk about why are we doing this in the first place? Who really cares if soil heats faster, or if water heats faster, or if soil cools faster, or water cools faster? Why does it matter? Well, we've been talking about temperature and what affects temperature. So what causes different temperatures in different places? So far, we've discussed how elevation, or how high up you are in the atmosphere, how that will make your temperature cooler. We've also talked about latitude, how if you are closer to the equator, it's going to be warmer because you're getting more direct sunlight, and as you get farther northern or south of the equator, it gets cooler depending on the season because you get less direct light. So we've talked about latitude and we've talked about elevation. Today we're going to talk about proximity to water, large bodies of water, or being surrounded by soil, or just being surrounded by land. Okay? Now, that's why this is going to matter at all. That's why we did this lesson and this inquiry in the first place. So I'm going to bring up for you a map that should look familiar. We've been looking at this recently. So if you guys remember, we were looking at three cities. San Francisco, which is right here, Denver, which is here, and St. Louis, Missouri. Now, when we talked about these three cities, we noticed a few things about them. First, we noticed that San Francisco is right on the ocean. It's right on this big ocean called the Pacific Ocean. So it's sitting right there next to a big body of water. So its proximity, or its distance from the ocean, is not very far. It's right on the ocean. Okay? Denver is surrounded by land. It is not close in proximity to any large bodies of water. It's actually, very far away from any sizable bodies of water. So Denver is not close to water, but it does have something interesting going on. It's actually at a higher elevation. That's why we're called the Mile High City. It's at a higher elevation than both San Francisco and and St. Louis. And then you go over to St. Louis, and St. Louis is not at a high elevation, and it's not next to any really large bodies of water, although it is right on a river, a famous river called the Mississippi River. Okay, so what is similar about these three cities is they're all at just about the same latitude, which means they're all about the same distance from the equator. So if we were just going by latitude, then we should say, well, they're all the same distance from the equator, they must have about the same average temperatures. But when you look at the cities individually, you'll see, okay, we've got St. Louis. During January, average temperature 29 degrees. In July, it gets a lot hotter. It's 80 degrees. So that's a difference in temperature of 51 degrees. That's the range from January to July. Okay? Then we go to Denver. Okay? And we see that in Denver, January, the average temperature is about 30 degrees Fahrenheit. And in July, 74 degrees Fahrenheit. Okay? So if you do that math, that's a difference of about 44 degrees. Okay? So St. Louis has a wider range than does Denver. Okay? And then you go to San Francisco, and you see that San Francisco is 49 degrees in the winter in January, and about 63 degrees in July. So it doesn't get all that warm in San Francisco, and the temperature range is actually not that much either. It's only 14 degrees difference between winter months in January and summer months in July. So the question is why? Okay? Now think about that. We've just been studying what cools faster, water or soil, what heats faster, water or soil. Okay. Now, we know that water heats very slowly and it cools very slowly. So let's look at San Francisco here. In the summer months, when there's a lot of direct sunlight coming into this area, And San Francisco is getting a lot of direct sunlight, so is the water. And the problem is that a lot of that water is reflecting that sunlight off. Now, if you've got a big ocean next to you, the temperature of the ocean is going to affect how warm your city is. Now, since the ocean doesn't heat up very quickly, neither does San Francisco. So during the summer, San Francisco is not really going to get that warm because the ocean takes a long time to warm up. Similarly, in the winter, after you get to August, you get to September, this ocean's been heated for a long time right around San Francisco. So it's got a lot of heat inside that ocean. Now, as it gets cooler and you're getting more indirect sunlight, so it should be getting cooler, the ocean really doesn't cool all that fast. It's going to cool very slowly because water cools very slowly. Similarly, San Francisco is going to cool down slowly. So, in the summer months, you don't have it very hot. It's 63 degrees. In the winter months, you also don't have it very cold, 49 degrees, because water does not heat very fast and it does not cool very fast. Okay, now we saw already that both Denver and St. Louis, they seem to have big temperature jumps. So 43 degrees, I think we said, and 51 maybe. I can't remember the exact numbers. But large temperature jumps. Now you're going to notice that both St. Louis and Denver are surrounded by land. We know that land heats very quickly. So when that land gets direct sunlight, that land heats the air around it. So in the summertime, when that land heats up, so does the city of Denver. Okay? It heats quickly, so does Denver. The land heats quickly, Denver heats quickly. In the winter, when the land cools quickly with the indirect sunlight, the city does too. Okay? So in the winter, it gets cold quickly, and in the summer, it gets hot quickly. Same situation here in St. Louis. Okay? St. Louis warms up really quickly because it's surrounded by land, and it cools down really quickly because it's surrounded by land. So at this point, we've discussed three different things that affect temperature. First, latitude, how far you are from the equator. Second, we've talked about elevation, how high up you are in the atmosphere. And third, we've talked about proximity to the ocean or big bodies of water, or being surrounded by land. So how close you are to a big body of water versus being surrounded by land is also going to affect your temperature. If you're near water, your temperature is going to rise and fall slowly because water's temperature rises and falls slowly. If you're surrounded by land, the land's temperature rises and falls quickly, so the temperature of that place is also going to rise and fall quickly. All right. So you're going to use that now to complete an assignment.